Hello everyone. Today we will see how to graph a curve. So for graphing we have to go through certain steps. I have written here 7 steps. First we will check for x and y intercepts. Second we will check for the critical points. That means the points at which the first derivative is going to be 0. And third point is point of inflection. That's a point at which y2 dash is going to be 0. Then you have to check for rise and fall of the curve. That means whether the curve is increasing or decreasing in certain intervals. That intervals is divided by critical points. Then we will check for the concavity, and that concavity also will check in between the intervals. That interval will be divided by point of inflection. Then we'll check for the possibility of cusps and then possibility of asymptotes of the curve. After checking all these steps, we can draw a curve. Let's see one example for graphing. Let's take the curve y is equal to x raised to 5 by 3 minus 5 into x raised to 2 by 3. The same curve I can rewrite as x raised to 2 by 3 into x minus 5. Just for easiness in the calculation, we will write in this form. So as I told, let's see one by one. First step, x and y intercepts. So let us give x intercept. Let us find x intercept. To find x intercept, we have to give y equal to 0. Y equal to 0 implies x raised to 2 by 3 into x minus 5 should be equal to 0. So this implies x should be equal to 0 and or x equal to 5. So you have two intercepts, that is 0 and 5, means the curve cuts the x-axis at 0 as well as 5. Now for y-intercept, let's take x is equal to 0. When x is equal to 0, we will directly get y equal to 0. Means the curve cut the y-axis only at 0. So here we have both intercepts. Now we have to go to find next part, that is critical points. To find critical points, we have to find y dash of the curve. Let's write y once again, x raised to 2 by 3 into x minus 5. So to find the critical point, let us take y dash equal to 0 or undefined. So these are the points at which there exists critical points. So let us find y dash now. So y dash equal to, let us use the other form for the derivative. So you will get 5 by 3 x raised to 5 by 3 minus 1 minus then 5x raised to 2 by 3. So 5 into 2 by 3 into x raised to 2 by 3 minus 1. So you have to see this is not going to be undefined at any point or not, or whether it is going to be 0 or not. So y dash equal to 0. Let us check first. Y dash equal to 0 means this equal to 0. So let's rewrite this once again in this way. 5 by 3 x raised to 2 by 3 minus 10 by 3 into x raised to minus 1 by 3 will come, that is x raised to 1 by 3 in the denominator. Let us write. So I can rewrite this once again. Wait, let me rewrite this y dash once again. Y dash is equal to, if I multiply I'll take 5 by 3 outside, then x raised to 2 by 3 plus 1 by 3 will come, that is 1, minus 2 will come, divided by x raised to 1 by 3. So here y dash equal to 0 when x equal to 2, and another situation comes here, y dash undefined, that is y dash undefined when x is equal to 0. So you have two possible critical points, that is at x is equal to 0 and at x is equal to 2. So the points are, when x is equal to 2, your point must be, let's give in this. So when x is equal to 2, your y value will be equal to, you can calculate the value and you can write this as minus 4.8. It is, let's calculate with the calculator. You can find this as minus 4.8, and when x is equal to 0, you will get this is also equal to 0. So these are the two critical points we have. Now we have to find point of inflections. That's our next step. We have done x-intercept, y-intercept, critical point. Now point of inflection. To find point of inflection, we have to find the second derivative of y. So let's see what is first derivative. First derivative is y dash equal to 5 by 3. Let's write that first. Y dash equal to 5 by 3 x minus 2 divided by x raised to 1 by 3. X minus 2 divided by x raised to 1 by 3, which is equal to, I rewrite it as 5 by 3 x raised to minus 1 by 3 into x minus 2. So I again write it as 5 by 3 x raised to 2 by 3 minus 10 by 3 x raised to minus 1 by 3. Now let's find the second derivative. Y2 dash equal to 5 by 3 times 2 by 3 times x raised to 2 by 3 minus 1, that is minus 1 by 3, minus 10 by 3 times minus 1 by 3 times x raised to minus 1 by 3 minus 1. So it will come minus 4 by 3. So this again I will write it as 10 by 9 x raised to minus 1 by 3 plus 10 by 9 x raised to minus 4 by 3. So for easiness, let us take the common terms outside. Then we will write it as 10 by 9, we can take it outside. Also x raised to minus 4 by 3 also I will take it outside. So the remaining terms I can write it as x plus 1. So y2 dash is this. Now to get the point of inflection, we have to equate y2 dash to 0 or y2 dash undefined. So y2 dash equal to 0 implies, this implies either x can be equal to 0, or from this you will get x is equal to minus 1. So when x is equal to 0 or when x is equal to minus 1, we can have y2 dash is equal to 0. And in similar way, y2 dash is undefined in which points? So I2 dash is undefined in x at x is equal to 0. the chances x is equal to 0, because when x raised to minus 4 by 3 it will come in the denominator, then at x is equal to 0 there is a chance of y2 dash undefined. So these are the points, possible points of inflection. So you can write the points as 0 and -1. So corresponding to 0, the value of y you can write it as a 0 the same, and corresponding to -1 you will get the point as -6. So this you can calculate from the function y. From here you can calculate when x is equal to 0 you'll get 0 definitely, and when x is equal to -1 you will get it as -6. So after the calculation you are getting 2 points of inflection, that is 0 0, possible point of inflection 0 0, and -1 -6. So these are points of inflection. Point of inflection. So we have critical point, we have point of inflection. Next we have to look for the rise and fall of the curve in particular intervals. So this point of inflection we have finished. Now we have to go for a rise and fall of the curve. So for that we will divide the entire real axis into an interval. So this is divided by critical points. So we have two critical points here, 0 0 and 2 minus 0 0 and 2 minus 4.8. So let us mark these two values in your x-axis. So here in the axis I'm going to mark 0 and 2. So this is minus infinity, this is plus infinity. So we have these intervals. So in these intervals we have to check for whether the curve is rising or falling. Okay, so what we are going to do is we will divide the function y dash as different terms. So here we have written y dash as 5 by 3 x minus 2 divided by x raised to 1 by 3. So we have to check in each interval whether this y dash is going to be greater than 0 or less than 0. So for this what we will do is we will write these terms separately, then calculate. So I'll show you how to do this. So let's draw a line here, a line here, then a line here, and a line here. So I'm going to write my y dash here now. So in my y dash I have two terms, one is x minus 2, the other one is x raised to 1 by 3. So the two terms I will write here, x minus 2, then x raised to 1 by 3, and then I will find y dash by finding dividing these two terms and finding the product with the constant 5 by 3. Okay, so let's see what will happen to these values in this interval. In between minus infinity to 0, your x minus 2, that is x minus 2, whatever be the values in between minus infinity to 0, x minus 2 will be a negative number. So let us put a negative over here. Now in between 0 and 2, if you give some value 1 over here, you will get a negative value only. So this also negative. And after beyond 2, you whatever be the value, you will get x minus 2 as plus. Similar way, x raised to 1 by 3. For a negative value raised to 1 by 3 will come negative only, and from 0 to 2 it is a positive value. So positive value raised to 1 by 3 is always positive, and here also positive value, so raised to 1 by 3 will come positive only. So you can check the sign of y dash by taking the division of these two signs. So minus value divided by minus value always will give you plus value only. then minus divided by plus will give you minus only, and plus divided by plus will give you plus only. So means your y dash will be positive between minus infinity to 0, and negative between 0 to 2, and positive between 2 to infinity. From this it is clear that your y dash is your curve is going to increase in this interval. If y dash is positive, the curve will increase, and if y dash is negative, the curve will decrease. Again, y dash is positive, the curve will increase. So you could understand how the rise and fall of a curve is coming according to the sign change of y dash. So that's a part, that the next step what we have done, that is rise and fall of the curve. Next, we will see the concavity of the curve. See from the list, you can see next is concavity we have to check. So to check the concavity, you have to look for the point of inflections. So the possible point of inflections we have found that 0, 0 and minus 1, minus 6. So in the real line, we will mark the point 0 and the point minus 1, and we will divide the x-axis into 3 intervals. Let's see how it is. So I'm going to draw the real axis now. So this is the real axis, and the points I have to mark is 0 and minus 1. So I marked 0 here, then minus 1 almost will come here. Let's take, so infinite, minus infinity here, plus infinity here. Similarly, I'll divide this in different boxes so that you can see how things comes. So now you will check the sign of your second derivative. That is second derivative we have. What is your second derivative? Second derivative is x raised to minus 4 by 3 into x plus 1, or x plus 1 divided by x raised to 4 by 3. So you will see the sign of these two terms first. That is x plus 1 and x raised to 4 by 3. X raised to 4 by 3. Then you will check for the sign of y2 dash. Okay, so let us see. Between minus infinity to minus 1, x plus 1 will be always negative only. I'll use another color for this. Negative only. And in between minus 1 to 0, x plus 1 always will be, let us take some minus 1 by 2, minus 1 by 2 plus 1 definitely is a positive number, so it is plus. Then from 0 to infinity, definitely it is positive. And x raised to 4 by 3, see, x raised to 4 by 3 same as x raised to 1 by 3 whole raised to 4, means something raised to 4 is an even number. 4 is an even number, so it is like a perfect square, so you can have only positive values. So minus infinity to minus 1, if you give, you will get raised to 4 of that, raised to 1 by 3 whole raised to 4, it will be plus only. And here also minus 1 to 0 you will get plus, and here also you will get plus because it is whole raised to 4. Now y2 dash is a combination of these two terms, that is this. So you can have x plus 1 divided by x raised to 4 by 3. So let us see what will be the sign of y2 dash. See, minus divided by plus will come, that will come minus only, and plus divided by plus is plus only, and plus divided by plus again will be plus only. So means the signs of y2 dash here are minus, plus, plus. So you can predict the concavity in such a way that here in this minus infinity to minus 1, it is concave, down will come because it is minus sign, and y2 dash plus in minus 1 to 0, so this is concave, up will come, and this is again plus, so concave, up will come. So here you can see the concavity changes. From minus infinity to minus 1, it is concave down, and minus 1 to 0, it is concave up. And you can see one more thing, from 0 to infinity also this is concave up. So this is the concavity of this curve. Now next step is you have to check the possibility of a cusp. So how to check the possibility of a cusp? So first thing, from the last scene, see, you can see around the point 0, this side it is concave up and this side also it is concave up, means the concavity is not changing at 0. So there is a chance to have a cusp at this point. So to check the whether it is a cusp or not, you have to check the limit. That means as x tends to, sorry, as x tends to, the point is 0, so you have to check for x tends 0 minus and x tends to 0 plus. If as x tends to 0 minus, if you are getting y dash, the value, what is the value of y dash that you have to check? Okay, as x tends to 0 minus and x tends to 0 plus, what will happen to y dash? You have to check. What is your y dash? Let us see what is y dash. Y dash is this. So as x tends to 0 plus, what will happen? As x tends to 0 plus means it is on the positive side. So this will come x raised to 1 by 3, that is a positive number it will come, and as 0 plus means it is closer to 0, so this is negative. So the entire term y dash is going to be negative, that is minus infinity it will come, because it is coming closer to 0, the denominator is going to be 0. So this is infinity and it will come a negative sign only, because numerator will come negative, denominator will come positive, so this is minus infinity. So here as x tends to 0 minus, you will get minus infinity. But as x, sorry, I have written in another place. As x tends to 0 plus, you will get minus infinity. But as x tends to 0 minus, what will happen? The values are negative. So in the derivative, x raised to 1 by 3, negative value raised to 1 by 3 will come negative only. And negative minus, again minus 2 is coming. That is again a negative value. So negative will be positive. So divide by 0 will give infinity. Means your limit as x tends to 0 minus will give you plus infinity. So as x tends to 0 minus, it is plus infinity, and x tends to 0 plus, it is minus infinity. So this implies at 0 there is a cusp. At x is equal to 0 there is a cusp. So two things you have to check for. First thing, at the point of inflection at the point of inflection case, the 0 concavity is not changing, so there is a chance for a cusp at that point. So here concave up and concave up, so 0 has a chance to have a cusp. In the similar way, if it is concave down and concave down, still there is a chance for a cusp. So, and if it is a cusp, it should come in this way. As x tends to 0 minus, you should get plus infinity, and x tends to 0 plus, you should get minus. Means it should be of opposite signs, it should come, so you can have a cusp. So at x is equal to 0, we have a cusp here. Now last part is you have to check for the possibility of asymptotes. That's our last part. See, possibility of asymptote. So we can have three kinds of asymptote. That is, first one is horizontal, then vertical, then oblique asymptote. Horizontal asymptote means that is parallel to x-axis, so means it will be of this form, y equal to some constant. Vertical asymptote means it is parallel to y-axis, so x is equal to some constant will come. And oblique is, it is neither parallel nor horizontal, neither horizontal nor vertical, so it can have like a function y equal to g of x. It can come like a function. So let's see what are the conditions for all these three. So for horizontal asymptote, we should have as x tends to plus or minus infinity, you should have y tends to some finite number a. So if this is possible, then you can have a horizontal asymptote. And in the opposite, as x tends to some finite number a, that means some plus or minus, you can take plus or minus can come, then y should go to plus or minus infinity. So in such case, you can have a vertical asymptote. And the third case is oblique asymptote. Oblique asymptote means it can come for a rational function only. For example, if y is equal to x square plus 1 by x. If this is the function we have to graph, you can see the degree of the numerator is 2 and degree of the denominator is 1. So degree of numerator is greater than degree of the denominator. In such situations, you can have an oblique asymptote. So these are the points to check for you to whether the given equation has a cusp or not. So let's see our equation. So this is our equation, x raised to 2 by 3 into x minus 5. This function don't have a denominator. You can tell like this don't have an oblique asymptote anyhow. And about horizontal and vertical asymptote. As x tends to plus or minus infinity, y never be a finite number. So this is going to be, there is no horizontal asymptote. And the other thing is, as x tends to a finite number, y should tends to plus or minus infinity, and that also will never happen. And x tends to a finite number, y also will tend to a finite number. So in all the three cases, there is no chance for an asymptote for this curve. So we have done all the steps here. We have got x and y intercepts, that is x intercept and y. Let us mark all those things. X intercept and y intercept, let us mark. These are the intercepts of with the x-axis, and this is with y-axis. And now the critical points, that we have two critical points here, that is 2 minus 4.8 and 0 0. Now point of inflections we have 0 0 and minus 1 minus 6, and we have rise and fall curve system and concavity as well. Then we have checked for the asymptotes and cusp as well. Before sketching the curve, let us prepare a summary of whatever we have found. So I'm drawing a real axis here. So I'm going to mark some points, that is critical points and point of inflection. So these are the critical points, and 0 and minus 1 were the uh, point of inflections. Now I'm going to make a summary about this. So let's mark the things. So both the ends it will come minus infinity plus infinity. So let's see. So from this slide, see, minus infinity to we have up to minus 1. So minus infinity to minus 1 we have to consider now, because in this section we have divided this into minus infinity to minus 1, then minus 1 to 0, 0 to 2, 2 to infinity. So we have to consider all the intervals. So minus infinity to minus 1, what will happen? So see here, in minus infinity to minus 1, the curve is definitely increasing and it is concave down. So let's mark it in this. So curve is increasing and it is concave down. So how it will look like? The curve will be in this shape. Okay. Now next, minus 1 to 0. In minus 1 to 0 also the curve is increasing, and minus 1 to 0 it is concave up it is. So let us mark it. It is increasing and it is concave up. So your curve will be in this form. Okay. Then 0 to 2. 0 to 2, here 0 to 2 is the curve is decreasing, and 0 to 2 the concavity is up only. So let's mark this. It is decreasing curve. It is decreasing and it is concave up. So you will get the curve in this way. Now you see at 0 you have a cusp I told. So see the curve how comes. At up to 0 it will come like this, and then it will go back down like this. So there is a chance of a peak point there. So next part, 2 to infinity. 2 to infinity, you can see 2 to infinity the curve is again increasing and it is concave up. So let's mark that curve is increasing increasing and it is concave up again. So it is increasing and up, so it will come like this. So this is the summary we have, and this is the point of cusp. Okay, now we will draw the curve. Now let's sketch the curve. See, I have plotted the graph, the x-axis and y-axis, and we have points that from the beginning. Let's see, we have intercepts at 0 and 5 and y equals 0, that is 0 0, the same point. So I have drawn that points here. See, the point 0 0, that is this point, and the intercept point, this one. So two intercepts I marked. Then critical points. Critical points, let's see what are the critical points we have, that are 2 minus 4.8 and 0 0. So the points are here 0 0 I marked, and 2 minus 4.8, that is this point. So I'll write here the point, that is 2 comma minus 4.8, and the other point was 0 0, so this is the 0 0 point. Now you have to check for point of inflection. Point of inflections, we have got it as 0 0 and minus 1 minus 6. So let's see, in this 0 0 I already marked, and this is minus 1 minus 6 point, that is again point of inflection. Let us write here minus 1, sorry, right on this side, minus 1 minus 6, this is this point. Now as we have made summary, let's see the summary. Minus infinity to minus 1, it is gradually increasing up to the point minus 1. This minus 1 minus 6 is the point, that x is equal to minus 1, then y is corresponding y is minus 6. So up to this point the curve is increasing from down. So let us draw in that way, from minus infinity to, it is coming increasing and increasing and increasing and increasing, it comes up to this, and afterwards it is again increasing, and this point minus 1 is a point of inflection. So there is a slight change in the increasing pattern. So just see, like this, it will come here and it will increase and increase and increase and increase, it will go up to minus 1, sorry, 0 0. So at 0 0 we are going to have a cusp. So it is a peak point, and it is next stage, it is concave down and it is decreasing. So our curve, and it is decreasing up to that point 2, that is 2 comma minus 4.8. So up from here to here it is decreasing and decreasing and decreasing, sorry, let's me, I'll draw decreasing and decreasing in this way. Then from there onwards it is again increasing and it is concave up. So it, and we know that the curve, it will cross the curve, cross the x-axis at 5. So this you can draw in this way, and it will increase and increase and it will cross the x-axis at 5 and it will go above. So this is a rough drawing of the given curve. Y is equal to, the curve is y is equal to x raised to 5 by 3 minus 5x raised to 2 by 3. So remember all the things, and you have to mark the points properly. So this is one point I have marked, and this is another point, and this is the third point, and this is the fourth point I have, and these 2 points are coming in 3 places. One is like intercept, and another like critical point, another like point of inflection, and it is going to be a cusp as well. So 0 0 has lots of properties here. And now and minus 1 minus 6, there's a point of inflection comes, and at 2 minus 4.8 is a critical point. So it is it's a local minimum point, it is, so that you can see from the figure, and this will give you a sketching of a rough sketching of the given curve. Hope you can follow the session. Thank you so much.